It's time for JT's session here. You see what I see, the resurgence of C++ for application development. John Thomas, or JT, is Director of Product Management over here at Embarcadero in Scotts Valley.
Thank you, Anders. Good morning, everyone. And thanks for joining my session this morning. Do you see what I see? A resurgence of C and C++ for modern application development. Thanks also to Seva for kicking off the conference this morning, so I didn't have to be here at 6 a.m. Of course, he's over in Russia, so he's a little later today. But I wanted to spend a little bit of time to share with you folks something that I've been seeing over the last, especially 5 years or so, which is C and C++ being talked about more and more, not just by vendors, but also by developers. And why is that? Why is it having this resurgence? Of course, resurgence may insinuate that C or C++ went away, but in fact, it never really did. It just didn't get talked about as much, and was used quite often in areas where the type of language used wasn't known to the world or to the outside world. And I'll get into more specifics on what I mean here in just a moment, but where I really had seen this was in Asia, in places like Taiwan and China and Japan and Korea, where folks were building small embedded systems. When I had, as many of you may know, I spent my early part of the career at Borland working on C++ products, and when I had left, I went to go work for an embedded systems operating system provider, which made embedded Linux. And in that particular area, all people talked about was C++ development. There was no other language choice. Well, there were choices, but 99.9% of the time, folks just used C and C++, and for many reasons. One, there's good compilers available for Linux. Two, people could get low-level hardware access, which was critical on these embedded systems because oftentimes they were building very specific applications for their hardware. They had specialized hardware on their systems as well. And thirdly, they could write very full-featured applications using the object-oriented features of C++. So it was a very important language for that type of systems development. So when asked, do you see what I see? I'll share with you what I was seeing this last weekend. I was actually out in Korea and Japan this last week, and this is a view from my room at the Tokyo Dome Hotel. Yes, Tokyo does look like Disneyland everywhere. No, it's a particular amusement park right there in Tokyo Dome. So it was a really neat view from the hotel. But like I was saying, in Tokyo, in Japan, and in Korea, and in Taiwan, China, these areas where folks are building embedded systems, C and C++ has always been important and has never really gone away. So to say it's a resurgence again is kind of a misnomer. It's really just that it's been in a different area where people have been focusing on using it. And that area, embedded systems, is really becoming prevalent again, more so than it ever has been. So following the theme of do you see what I see, well, as many of you may have heard, there was a big earthquake in Tokyo, or well, in Japan anyways, north of Tokyo on Friday. This is the building I was in. It's basically 4 stilts on an upside-down pyramid. Looks a little top-heavy. We were right there on that bottom floor of that building, which was called the 6th floor. It seemed a little higher up than that. But we had a wonderful developer camp, hundreds of developers, live streaming of our sessions, and we were talking about all sorts of stuff, but mostly about C, C++, and our new C++ release, which we'll be spending some time on after a conversation with Bjarne Stroustrup. We'll be having a product address to get into some more details on our release. But this building was shaking, and so I definitely felt that earthquake. That was my first experience with an earthquake in Japan, and it was a little scary, but especially in that building right there. So I just want to spend a little bit of time. Probably most of you on this call know the history of C++, but I think it'd be fun to kind of remind folks of the fact that C++ is going to be 30 years old. Let's see, here shortly. It's actually has a very long and illustrious history. So where did it start? Well, most of computing started at Bell Labs. They had a very specific problem they were trying to solve, switching of data and voice across hundreds of millions of lines. So they built systems that were, first of all, very, very stable, and then secondly, allowed them to take advantage of the hardware that they had and get the best performance possible out of that hardware. So Bell Labs, in addition to creating Unix, which is the underpinnings of much of computing today, also had created the C programming language with Kernighan and Ritchie, and finally C++ with Bjarne Stroustrup, who was at Bell Labs at the time as well. Around 1979, I've heard Bjarne was trying to build a system that was a little more flexible to use, much like Simula or Ada, some of the object-oriented properties of those languages. And so he built C with objects. And the goal here was to provide that level of abstraction, but to continue to have a syntax and a runtime library that was based on C, because that was the core language of the time. So it was a fairly primitive language, but it had basic object-oriented properties like encapsulation and inheritance. And the compiler at the time basically took C++ code, or C with objects code at this time, and created equivalent C code that could then be compiled by a traditional C compiler. So this was the early days of C++. In 1983, the name was changed to C++, and it was largely known as AT&T C++. AT&T actually published a specification on what the C++ language was, and continued to publish a specification and gave it a versioning system as well, so developers would know what they were supposed to be able to use in a particular version of C++. So in 1983, the name was changed to C++, and started getting more of the modern features of the time, like virtual functions and operator overloading. And most importantly, what you started to see was commercial compilers being made available for other developers. So AT&T actually published a C-front compiler at the time to allow other developers to be able to create C++ applications. This specification actually allowed other vendors, third-party vendors like Borland at the time, to also create offerings and deliver C++ compilers. So this is an old Turbo C++ professional ad, and you see one of the top features for the professional compiler is that it conforms to AT&T's 2.0 specification. So that was an important thing for a C++ compiler vendor to be able to provide support for the specification, because other compiler vendors were also starting to deliver solutions, and C++ code has always been built around the premise that it could be cross-platform or multi-platform as long as vendors supported the specification. So this was an important aspect of any C++ compiler, commercial C++ compiler at the time. But notice there's many other features besides just a specification. Borland, I think, was definitely ahead of his time in recognizing how to make developers more productive. And Turbo C++ was more than just a compiler. It was also a debugger and an editor all in one. So really the beginnings of integrated development environments started with the Pascal Turbo C++ lines. This, in fact, was my first compiler as well. So in addition to having a compiler that conformed with the AT&T specification and an IDE so that developers could edit, compile, debug in the same environment. There's another thing that Borland did that I think was also very future-looking, which was to provide class libraries and application frameworks. So one of the application frameworks at the time, many of you may or may not be aware of it if you'd used the product, but there was an application framework called TurboVision. And basically this was a UI building library for building graphical applications in DOS. And in fact, Turbo Pascal, Turbo C++ were written using TurboVision. So in addition to just being able to support the language and the productivity of an integrated development environment, application frameworks were recognized as a huge part of the value of these releases, and in giving developers access to supporting the particular operating system they were working on, especially with regard to graphical applications. Because C++ never really dealt with having a common UI layer or how to support graphics across multiple operating systems. Part of the reason is that every operating system had a different approach to how it created graphics. But C++ also allowed the language to be extended or modified to be able to support these UI libraries on these individual operating systems. So Microsoft, of course, was an early adopter of C++, and their core Win32 API was written in C. So this is when Borland started moving into providing support, both in terms of compilers, as moving from 16 to 32-bit, but also in providing application frameworks that worked on Windows as well. And for Windows, there were really primarily two C++ frameworks at the time. This was during the 90s. The Object Windows library, which came from Borland, and the Microsoft Foundation classes. And both of them were definitely C++ application frameworks. So, some may argue Object Windows did a better job of abstracting Windows, making it it was a little better designed in terms of how you created windows and managed message loops and all the kinds of things that both of these libraries were trying to make easier than the pure C approach of using Win32 API. But markets being as they are, oftentimes the better technology doesn't always win. MFC got a very broad acceptance and usage across the board for C++ on Windows. Now, around this time also, even though AT&T had provided a standard written around C++, they also decided that to really help it succeed, they wanted to make it a broader specification, a standard. And so they utilized the Foundation's ANSI and the ISO organizations to shepherd a standard through a public standardization process. And so in 1998, the gold standard, if you will, was made available, and this was the first standard C++ that was made available. Since then, there's been several other standards and specifications that have been released, and culminating this last year with a brand new specification, colloquially known as C++ 11. So C++ 98 did a couple of interesting things, I felt, to make C++ a very modern language. In addition to thinking about language features, and some of these were pretty significant, such as support for multiple inheritance and templates, so generic programming. C++ in general supports many different types of programming paradigms, but this is one of the first to really support generics in a strongly typed language. introducing the notion of namespaces and typecasting. And these are things that you see as part of any modern language today, like Java and C# as well. So these were important features that were in development over the years and became part of that gold standard back in 1998. But one of the things that they also did, which I think was just a really had some very good insight, was to make a library available as well. And you could think of this as the C++ RTL. So the CRTL deals with things, and in any language RTL deals with things like file I/O, memory management, and a few other facilities like that give you an interface into the basic operating system that you're working on. The C++ RTL, known as the Standard Template Library, because they were written using C++ templates, provided many of these same features, but in a way that made it much easier to use. So there was strings, a streaming library. So this was used for both file I/O and memory, moving values through memory. It used syntax that also used a new feature of C++ 98 at the time called operator overloading. So this usage of stream insertion and extraction operators were everywhere. And it was pretty common to write a class that in order to put its output out into the console, for instance, you would overload your own stream insertion operator or extraction operator as needed. But additionally, and this is one of the things I think is very powerful in C++, was the container classes. So STL contained many of the common data structures that all programmers needed to use. Things like arrays and lists and binary trees and maps and all the common type of data structures that were used at the time, as well as algorithms that knew how to operate on top of these containers. So, for instance, you could have a common sort function that could take a vector, which is basically a fixed array, or a list, which is like a linked list, or even a binary tree, and it could sort them all equivalently. It didn't need to know necessarily the details of the data structure, or at least you didn't need to provide it those details. You just needed to provide it what was called an iterator, and the iterator knew where to start and where to end on this particular container. So it provided a common algorithm library that was easy to use for any type of data structure and data that you were working with. And this really gave a notion of reuse to the developers for C and C++ development. So C++ 03 and TR1 happened over the last 10 years as well. 03 really was a bug fix release, and the spec didn't change. It was still the 98 spec, but they addressed any kind of inconsistencies or issues with the spec at the time. TR1, which came out in 2007, was really about library, and those of you who are unfamiliar with or who know Boost know that much of the standard library began its life as part of Boost. So Boost is an open source library that's a very important library for C++, in that many of the features that you see today, for instance in the C++ 11 spec, had been part of Boost for many years. Things like regular expressions, smart pointers, hash tables, random number generators, et cetera, et cetera. And so these functions or features would live in Boost, and depending on the amount of acceptance or usage or pickup, they either would move into or become part of the language standard or become part of the standard template library. And so there's a couple of really good examples in C++ 11. For instance, C++ 11 introduced the notion of lambda functions. And Lambda functions can have many uses, such as creating anonymous functions, but can also be used to create things like functors, being able to specify an argument, a function dynamically, and then assign it to a pointer value. So, and this feature prior to C++11 was part of Boost. It was the Boost bind a function that you would use to do a similar thing. And this turned into essentially a feature of the language. So C++11, which was ratified last year and had been known for the last 10 years prior to that as C++0x, you can see that the standards committee has been very busy. There's a lot of new features that have been made available, and largely to simplify some aspects of the language, make it more accessible to more developers, and at the same time, make it more flexible and powerful, and bring in some ideas from other languages as well that were working very well. So even though, for example, a garbage collection standard is not part of C++, it allows the use of garbage collected implementations. So C++ has always been about additionally allowing people to, or vendors more specifically, to be able to extend the language to support very specific types of things that they're trying to do that may not be part of the specification. And one of those areas is, in particular, is around application frameworks and UI frameworks in particular. So let me give you the perspective from the vendor side a little bit. C++ has been an important language for this company, and going all the way back, as we talked about, to the Turbo C++ days, and through the Borland years of building application frameworks and supporting a standard language at the same time, and moving into today, which is this world where there's many more operating systems that we need to manage as well. So there's quite a lot going on, and I'll spend a little time talking about how we perceive the challenges and some of the solutions around that as well. So we talked a little bit about Object Windows Library. Some of you may remember that library was basically meant to encapsulate Windows development. So if instead of creating a Win class and specifying all the properties, you would create a T window. So what was 50 lines of code became essentially one line of code. Instead of writing a WinProc and dealing with a big switch statement to deal with all the Windows events, you basically created an application class that allows you to easily create event handlers, and like in the case of Al, they created many of these common event handlers for you. So that's what most application frameworks are trying to do, which is to encapsulate and to make some type of programming problem much easier to work with. So you write less code and you take advantage of the quality that's built into application frameworks because the vendor presumably had spent time thinking through the problem and testing the framework so that you gain the benefit of their effort in making sure that it's a high performance and high quality framework, so that you can spend a lot less time writing code that works. And again, that's really the main value of a framework. But C++ used the inheritance approach, and in some cases multiple inheritance. And this essentially meant that the way that the application framework worked at runtime was that it used vtables to make sure that it called into the correct object method depending on where you were in the application hierarchy. And it really relied on pure code generation to be fully compiled and to the dynamic aspect of the features came through the ability to cast into the proper class through the inheritance chain, and then counting on vtables to provide the right pointer to the method that you're working with. And this is definitely workable, but also was brittle. It was often difficult to extend classes, and you had definitely very strict rules around binary compatibility. So this was, this was kind of a workaround. Oftentimes classes would be written that had extra spaces for functions that quite haven't been thought through yet, just so that you can make sure that you had space to build out additional features as you went on. So it definitely was a little more brittle in that respect, though it did the job of encapsulating Windows very well. Contrasting that to something else that Borland had been working on at the time, based on its Object Pascal language, Delphi, and that is the Visual Component Library. So again, same problem trying to be solved, which is encapsulating Windows and making it easier for people to develop those applications. But as opposed to the C++ approach, it used a delegation model, and which meant that it supported method pointers and closures. So as opposed to casting and looking up the location of a function in a vtable, it would know who its delegates were and be able to create closures and bindings to be able to call out to the proper methods for the object that it was working with. But a couple of other really key things came out of this approach, and that is the availability of properties, a streaming system that allowed a UI to be specified using text and deltas of text, and finally, it really had a reliance on rich runtime type identification. So RTTI was critical for a library like this to work. And around this time when OWL and MFC were competing, VCL was being brought to market and did exceedingly well, because not only did it provide a very good encapsulation, but it also provided a development experience that was visual and very easy to work with in terms of building applications and quickly getting to market with those applications. So around that time, the C++ team decided that let's make C++ work with the Visual Component Library. And that meant quite a few things, which was take a standard language that has certain facilities and make it work in a way that wasn't exactly how it was designed for. And so the team built a C++ builder product, which extended the C++ language slightly to add some of these features, but it was able to deliver that full VCL development experience to other developers, so that you can get a full design time experience and have a very dynamic runtime environment. So this is a very successful project, and as many of you on the line know, this is C++ Builder, the C++ Builder of today. So Delphi and C++ are very closely tied to one another, and C++ Builder continues to support, of course, the latest features of Delphi, but also is continuing to support the latest features of C++. So just a quick look at RTTI and the extensions that were created. We call them PME extensions, property method event. What you'll find is that pretty much any modern language that has an application framework uses the same concepts of PME and RTTI. Java has a lot of these features, and C++, or I should say .NET languages like C#, as well as in the new WinRT from Microsoft, their C++, all have features that create these types of features like RTTI and PME. So in contrasting the two, though, you'll see that C++ Builder uses a syntax or a naming mechanism of this double underbar feature, for instance, double underbar property. And this is how C++ allows vendors to extend the language in a standard way. So this is what we call Embarcadero standard C++ extensions, the ability to, for us to extend the language to support our frameworks, VCL and FireMonkey, and to support these delegate-based frameworks, which is, again, how you'll see most modern frameworks using a delegate-based model, like, for example, .NET as well. So on the WinRT side, you'll see many of these same features, including some extensions to the syntax for things like smart pointers as well. But again, any modern compiler vendor, application framework vendor is going to have this approach of extending the language to support specific features and these features around the dynamic approach to working in delegate-based frameworks. So that kind of brings us up to today, and why is this still important? Why is C++ more important than ever? There's a lot going on in the market. And first of all, I think most of you will recognize, or maybe not, but C and C++ is everywhere. It's in your car, it's in planes, it's in, of course, in your computers, it's in switches and printers, and one of the things you'll see in common in all of these is they all have a specific purpose or have an embedded element to them. Maybe not so much on the laptop and PC per se, but most of these other devices have an embedded purpose around them. But C and C++ also has been as strong as ever on modern operating systems as well. And as they grow into this world of multi-device, so what we're seeing is, when I was working at this embedded Linux systems vendor, and all people were working with was C and C++ for these embedded systems, well, what we see today is this embedded systems market is today's device market. All the same notions of development, and there's a question on, oh, okay. And so all of these devices have that common element. They're basically, in addition now to being embedded devices, they also are full-fledged operating systems on them as well. So in the past, I guess one of the big differences is that in the past you had a very specific, maybe it was an RTOS, that was a tiny microkernel that was used to run one or two applications, but now you have more general purpose computing environments, though in this embedded device form factor, so that the characteristics of small and fast and flexible getting hardware access is still alive and well in these, but you have these very full-fledged operating systems in them as well. For instance, Mach BSD in iOS, or the NT kernel in Windows, on and on. And of course Android as well, which is a Linux-based kernel, which is, you'll see in many of these other types of devices that are specific, have specific purposes. And the evidence is out there in just basic data too. I mean, for client devices in particular, you find C and C++ used everywhere. It's number 2 and 4 for the languages used in SourceForge. And I'm using C and C++ interchangeably in this regard. But I think even more telling is even standard applications that we've been using for the last 10 or 15 years are written in C++. So, for instance, you see, Microsoft Word. Well, I mean, Microsoft's had .NET out for 15 years, and Microsoft Word is still written in C++. Adobe Photoshop, pretty much any modern browser out there, every single operating system, database servers, et cetera, et cetera. This is top commercial software that is continuing to be written in C and C++. So this confluence of the fact that these embedded devices are everywhere now, coupled with the fact that they're built on top of full-fledged operating system, is this C++ is coming at it from both ends. And this is why we're seeing this resurgence in quotes. It's really just the fact that it's at the forefront again, because that's how these applications are being delivered. Even top web companies like Facebook and PayPal and Amazon, they all use C++ for their internal systems. For instance, Facebook even open sourced their C++ libraries recently. So, even though they present their product as a web product, C++ is absolutely critical to those programs. So just another look at C++ and its relative importance out there through various indexes on the web. It looks like I got a couple of extra slides in there. And this is a chart that comes from many different indexes from TOB. This is from LangPop, that shows basic interest in the language around the web via either searches or certain websites or many different other factors to gauge the interest. But C and C++ right there at the very top of the charts. Oh, I see. I'm going in the wrong direction. Okay. So as I was talking about, this has been a change. In the 1990s, when C and C++ were king, there was a large growth in desktop applications, and the client, a rich client that needed performance was important. It was a really nascent client-server architecture around that time as well. But most server-side apps were just basic web apps, and the web was really in its infancy at the time. And around 2000, folks were trying to take this notion of web, which was the thin client approach, and started using languages like Java and others to build basically server-side applications that generated HTML. Most of the UIs were around HTML, and the back-end systems were built with these large systems languages like Java. But in 2005, this was around the time that I was working in the embedded space, but we saw in the commercial side, especially, device development really kickstarted by Apple because they had such success with the iPod and iPad and building a application market around that we see device development becoming, in client-side development with high-performance client-side applications becoming important again. And in 2010, 2012, this device growth is just tremendous. It's everywhere, and it's really driving application development. So in addition to iOS, we also have Android largely driving a lot of these. So even though the server side isn't still important, it's just being leveraged in different ways. And client-side development, where performance and size and access to the device features really matters, and that's where C++ really shines. And so native is really key for a client-device user experience. The server approach, where virtual code of Java.NET was used to build server-side applications with code safety and protection, that's what they cared about. And performance scaling wasn't done by tuning code. It was just done by adding more hardware and load balancing the application. So that was basically the approach at the time. And the web user experience was network bound. So it had to talk to these server applications that, again, were being scaled by adding essentially hardware on the back end. Contrast that with today with client-side devices, where the user experience performance on the device is what's paramount. That's what's key. And scaling performance can't be done with hardware. Your hardware profile is fixed to whatever it is that you have on that device. And the user experience is typically bound to whatever it is that you're working with on that hardware. And this is, again, why native code like C++, Objective-C, and Delphi have become so important again in this world of multi-client, multi-device application development. So it's all about the client, again. So, I'm going to run through a couple of these slides pretty quickly because as we get towards the end here, we do want to spend a little bit of time setting up to host Bjarne Stroustrup and make sure that we have enough capacity for the attendance. So we'll probably spend about another 5 minutes on this, but I just wanted to kind of look at it from another perspective, which is from the enterprise, and the fact that the world in 1999 was really just about Windows client-side development. And as we discussed around 2005, web became an important platform which was being delivered by server-side applications. But today in 2012, it's all about multi-device. So in addition to Windows and Mac, on mobile you have, again, many different operating systems, but primarily iOS and Android today. So this is really a huge opportunity for building multi-platform applications for developers. It's all about these little devices that we carry around and that do almost everything for us, in addition to making phone calls, being able to get network access and access the web, and all the different applications that make these devices useful for us. But one of the things that all these devices have in common is that they all actually very well support C++. And so I'm going to talk a little bit about what each of them does here. Windows 8, especially with their new WinRT release, has really made C and C++ a first-class citizen again. So last 10 or 15 years when .NET was really the primary application framework, C and C++ were kind of relegated to the side for C# and VB and others. But in WinRT, C++ is the primary native language for writing WinRT applications. So Windows, or Microsoft, I should say, does recognize the absolute value of C++ in this device world. BlackBerry is going through a similar transition. Research in Motion, BlackBerries used to use just Java for application development. It was basically a version of J2ME that had grown over the years. But C++ in their new operating system, BlackBerry 10, is the native approach to writing applications. That's the only language you can use for developing native applications. They do support web, of course, and so do all these other phones, but C++ is the native language of these platforms. When people talk about Android application development, you often hear them talk about a Dalvik or the Java approach, because that is how Google has presented development, the language of development to most of its developers. But if you weren't aware, they also have a full-fledged native developer kit. And it's actually a very full-featured C++ development environment. So you can write full-fledged C++ applications on Android using the NDK. Most of the features that you need are available through this NDK, through standard C and C++ style classes. And those that aren't, you can connect to Dalvik through a JNI bridge. And then on the iOS side, Apple, of course, presents Objective-C as the primary language, which is a C-based language. But if you didn't know, it actually uses a compiler front end that is the same front end and architecture of a major C++ compiler, which is called CLang or Clang. So there is a full-fledged C++ compiler that's available for building Apple applications. And in fact, a common model that I've seen for developers who are trying to build multi-device applications across all these operating systems, especially those that have existing C++ source code, which is almost all enterprises, they are taking an approach where they try to reuse as much of that code base as possible, because of course building code bases and maintaining code bases is expensive, especially if you're trying to do multiple code bases. So trying to get to a single source code base strategy is pretty critical in this multi-device world. And so oftentimes what you'll see is that they write the presentation layer in the native language of that environment. So they may write an Objective-C UI or a Dalvik UI, and then talk to their C++ source code underneath it. So these are the various languages and classes that are the primary native, in quotes. And I say in quotes because the term native has changed over the years to mean basically whatever the native language is of that environment, where we know historically formerly we used to mean compiled language. So on BlackBerry and WinRT, you have full compiled language, the same on iOS. And Android, of course, you have Java. But the strategy here is use as much of that C++ source code across all four of them, and use as little as possible of the native library and language for that particular format. And we've also seen this being done now with HTML. So building that presentation layer with HTML, JavaScript, and CSS, and then use your C++ source code below, which gets them even closer to the single source strategy. So it's really two languages you're working with, but you're really managing a single source code base across all four platforms. And in 2013, and we'll get into more details throughout the year, but we'll be providing mechanisms for you to do the same thing using the FireMonkey framework across iOS and Android. So it's getting to that state of single source across multiple devices is how you're going to win in today's world of multi-device development. So I'd like to just quickly summarize, and we may have a few minutes for questions. But after this talk, we have, of course, are hosting Bjarne Stroustrup, and David and I will have a conversation with him about C++ and the new standard as well. And then after that, we'll be doing the C++ product address, where we can get into some details of what we're doing to support C++, the standard, as well as supporting multiple device development. But in summary, C++ has been around a long time. It's coming up on its 30th anniversary, but it's really more important than it ever has been. And this is largely because of this device growth and the importance of client-side application development, and along with that, the importance of using a native compiled language like C and C++ to get the most out of that platform. So, look for these single source opportunities. C and C++ seems to be a great way to deliver on that across all these operating systems. I hope I've shown that to you as well. So I'll go ahead and take some questions, Anders, for a little bit, maybe for about 5 minutes, and then we'll get prepared for Bjarne's talk.
With the release of C++ Builder support, will the release of C++ Builder support newer platforms as they become available, or will developers have to purchase new tools for the future?
Well, as you'll learn in the product address, we definitely are working towards solving this multi-device problem for you with Delphi and C++. So that means that we will definitely be supporting new platforms and taking our tools to each of those platforms. How we go to market with that in terms of what products, how we're going to build products around that, we haven't actually shared any public information on that yet, but we will definitely be supporting and building out solutions in particular around iOS and Android here in 2013.
All right. If you have any more questions for JT, please put them in right now. There are actually...
it looks like David answered most of them for me. Thanks, David.
Yeah, and these were also from the previous session as well. He was putting in written answers. I don't believe there's any other particular questions for you at this time.
Another chance will be during the product address.
Of course, yes.
Which will be at 10 a.m. or sorry, 9 a.m.
Yeah, in an hour and 10 minutes, something like that. How soon is C++ 11 support available? Today. It was launched today.
That's right. Actually, I'm going to announce it at the product address, but we did put out a press release that our new 64-bit C++ compiler was made available today, which is our first tool chain to fully support the C++ 11 specification.
Any plans for auto garbage collecting implementations in C++?
We do have some ideas around memory management, making it easier. Garbage collection may be a little too heavyweight, but we are looking at things like reference counting approaches. So we'll share more details with that as we start getting closer to delivering our mobile solutions. But yeah, we're definitely looking at, especially as we work with the FireMonkey framework across multiple devices, ways to help with memory management.
So with that, I want to thank JT for that presentation.
You're welcome.